Before now, we learned to use a sketched graph to generate equation that governs a physical system, which a particular process represents. Now, in lesson number 16, we want to learn how to use a plotted graph to generate an equation that governs a physical system. Now join me as I use slope and intercept obtained from the graph plotted for our foregoing case to create an equation that governs a physical system, which this process actually represents. Please cooperate with me.
Now let's use the graph we have plotted to find the equation connecting x and y of this table. To derive the equation connecting them, we first take note that the graph we have plotted from line of best fit is a straight line graph. If it had been a curve, a different scale would have been used from the one we propose to use right now. But because this is a straight line graph, we intend to use this equation, y is equal to mx plus or minus c. Let's recall that y stands for dependent variable, m stands for slope, x stands for independent variable, while c refers to vertical intercept. This is plus or minus because the intercept either leads or lags. In any case, from the way this equation is, the first step we have to take is to find the slope of this straight line. And later, we'll find the intercept. Let us start with finding the slope. Let's see. As usual, to find the slope, we draw a right-angled triangle as the one you can see on the screen. See it here. This is a right-angled triangle. And when we have done this, the next thing we do is to follow the procedure for finding slope. What is the procedure? It is by means of a formula. Let's recall the formula. The formula for calculating slope is given as change in y over change in x. Don't forget that change in y is given by y2 minus y1, while change in x is given by x2 minus x1. Now, we use this to find the slope from this graph we just plotted. The next thing is for us to carry out substitutions. We are supposed to find the value of y2 and place it here, value of y1 and place it here, value of x2 and place it here, and value of x1 and place it here. Let us start with finding the value of this y2. Let's see. First, where is this y2? It is here. It is the value of y at this point. That is called y2. Please, this is not the y-axis, but it is parallel to y-axis. So what we do is that if we must find the value of y2, we trace this to the y-axis, to this point, which means it is the value of y at this point that we refer to as y2. What then is the value of y at this point? To get the value of y2 at this position, we know that this point is marked as 12, but this position is not marked at all, yet it has a value. What then is its value? To get its value, let's go back to the formula for locating tabular values on the axis. The formula is n is equal to v over b. Don't forget what each of these variables stands for. The v stands for the value, b stands for the value of 1 unit box, while this v stands for the value of what you want to locate. and then n means the number of unit boxes from origin, which must be counted along the axis to locate this value. At this point in time, with these three variables, and with respect to this point, which of them is missing? The b is not missing. The b for vertical axis still remains 0.4. What about this n? N is not missing because we can count from here to this point and tell how many boxes there are, which means this is known and this is known. What we don't know, therefore, is the value of y at this point, which means v is now going to become our subject. This is why to find v, we change v to become its subject. It then reads this way: v is equal to bn. Please confirm that this is what we get when you make the v the subject. Again, v is equal to bn. Since b is constant, let it be this way. V is here, and then this b is now equal to is 0.4, and this n is n along the y-axis. Therefore, the formula for knowing the value at every point along this axis is this: v is equal to 0.4 ny. I repeat, the formula for finding the value of any point chosen along this y-axis is v is equal to 0.4 ny, which means if I choose this point, with this I can tell what it is. With this I can tell what this point is. With this I can tell what this point is. With this I can tell what value is attached to any point I choose to locate along this y-axis. So any place you choose, this is what you can use to tell what the value of that place is. Again, v is equal to 0.4 ny. So now 0.4 is known. Ny must be found. So we can simply say 0.4 times that number of boxes. Let's count from here to here to know the value of ny. So we can know the value of y at this point. Let us see. Ny from here to here, let's count. From here to here is 10. Here to here is 10. That is 20. Then 21, 22, 23, 24, 25, 26, 27, 27 and a half. That is 27.5. So ny is equal to 27.5. Let us now know the value at this point by putting 27.5 in place of this ny. Let's see. Now we see that since this ny is 27.5, 0.4 is still where it is. 0.4 ny means 0.4 times ny. That is 0.4 times whatever ny is. And we counted ny to be 27.5, so we place it here. Therefore, we have that value of y at this point is equal to 0.4 times 27.5. The answer is equal to 11. Therefore, y2 is equal to 11. This y2, which is here, is equal to 11. The formula is not difficult, but what might be challenging is how to know the value of each of these variables in the formula. So far, we have known that y2 is equal to 11. What about y1? Let's see. y1 corresponds to the value of y at this point because it came down from here, then to this point. So the value of y at this point is what is called y1. That means we count from here to here to get the value of this y1. How do we count? Let us do it again. From here to here is 10, then 11, 12, 13, 14, 15. So ny is 15. Let's see what the value of y will be at this point to correspond to y1. Let's see. Right. Don't forget that. Right. Recall that this ny from here to this point is 15. So we place 15 in place of this ny so that the value of y at this point is given by 0.4 times 15. So v is equal to 6, so that y1 is equal to 6. This is y1, and we have seen it as 6. Therefore, y1 is equal to 6. Let us turn attention to x. Now, let's now turn attention to x2. What is the value of x2? Please, from here to here means that this end corresponds to x here, and this end corresponds to x here. Whatever is here is called x2, and whatever is here is called x1. Therefore, what is that which is written here? Anyway, it is just a mere coincidence that at this point, we have this point clearly marked as 2. But we can still get these 2 by calculation. But first, what do we do to get the value of each position along x-axis? Let's find out. For us to get acquainted to the use of this formula in different ways, both for locating tabular values and for determining the value of a position along an axis, we have to make use of it. It is true that this 2 is already marked as the value of x2, but let us still make use of it to confirm. Again, we recall that the value of any place along any axis is v is equal to bn for all kinds of straight line graphs. Then, where b stands for the value of one box and n stands for number of boxes that must be counted from origin to locate the value v which you are looking for. Now, with respect to this graph we have just plotted, v, see it here, is equal to the b for x. Remember, we found it to be 0.1, no longer 0.4. 0.4 was in the case of this y-axis. But now we are dealing with this x-axis. It is 0.1. So an n is now nx, no longer ny. It is now number of boxes counted along x-axis, not ny. Therefore, the formula for locating or for determining the value of every point chosen or pointed along the x-axis is that v is equal to 0.1 nx. Now, from here to here, which is something as saying from here to here, how many boxes there are there is what we refer to as this nx. Let's count from here to here and replace this nx with such number. Let's count. From here to here is 10 boxes. From here to here is 10 boxes. Altogether, 20 boxes. That is how it now became 0.1 times. This nx is now 20. 0.1 times 20 is that v is equal to 2. That is why we say that this point is 2. So whether we see it as being marked or determining it by calculation, v at this point, which corresponds to x2, is equal to 2. We therefore confirm that x2 is equal to 2. Now, what about x1? x1 corresponds to this position, this point. What is it going to be? Let's find out. To find the value of x at this position, at this point, that is at this point, we simply replace this nx by number of boxes from here to that point. And how many are they? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 boxes. That means we replace this nx by 8, and we now have that v is equal to 0.1 times 8. 0.1 times 8 is equal to 0.8. Therefore, the value of x at this point is 0.8. Because it is going towards the left of the origin, it is minus 0.8. See it here. x1 is equal to minus 0.8. That reminds me, the former y1 was written as 6, but now it is corrected. See it here. It is minus 6. Why? The same reason. The y1 was gotten below the origin, and then x1 was gotten on the left of the origin. To reflect these things, we have to put minus. Let us now go to finding the value of the slope, so that we use these values, y2, y1, x2, x1, in substitution to get the value of the slope. Let's make progress. Let's now get the slope by the substitution. So this y2 is 11. Minus have been there, it is still here. This y1 alone has another minus. That's minus 6. That is why another minus is here. I hope you are following. Over x2. x2 is 2. See it here. Minus, it is also here. This x1 carries another sign, another negative sign. This is that negative sign. x1 is equal to minus 0.8. Place it here in the bracket, so that in the end, we'll have our slope is equal to 11 minus 6 over 2 minus 0.8. I hope you know how this became this, and how this became this. If you are confused as to what made them become these values they have become, please go back to Principles of Mathematical Operations. Therein, you will also see that what has happened here is not mathematically incorrect. Let's continue. Whichever way, this becomes this, and this becomes this. 11 plus 6 is equal to 17. 2 plus 0.8 is 2.8. If you divide 17 by 2.8, it gives you approximately 6. Almost accurately, 6 is what it is going to give to you. Therefore, the slope of this graph is equal to 6. So far, we have known the value of m. Next is the value of c, the vertical intercept. Let us see how to go about it. Regarding the intercept, the line we plotted crossed the x-axis at this point and crossed the y-axis at this point. What it means is that the vertical intercept is here, and here corresponds to horizontal intercept. But for the sake of this equation, we are looking for the vertical intercept. Therefore, it is this point that we have interest in. What is the value of y at this point? Let's find out. It is this point that we have interest to find. Let us find the value of y at this point. How do we do it? We again go back to the former formula of finding the value of y along this axis. Let's go back to it. That is it. We recall that v is equal to 0.4 ny is the formula for finding the value of a position chosen along the y-axis. Counting from this point to this point, we have 2.5 unit boxes. We now replace this ny by 2.5, and so we have 0.4 times 2.5. So the value is that v is equal to 1. That is, vertical intercept is equal to 1. So far, so good. We have found the value of the slope and the value of the vertical intercept. Please, is this 1 just plus 1 or minus 1. Notice that this 1 is below origin, therefore it is minus. At this point, we write that the intercept is equal to minus 1. See it here. The value of the vertical intercept, that is C, is equal to minus 1. Let us now go back to the equation we want to derive. So far, we've seen that the slope is equal to 6 and the intercept, vertical intercept, is equal to minus 1. So by substitution, we get the equation for this table. The equation connecting the y and x as y is equal to 6x. This plus or minus is minus here. Then c, 1. Therefore, y is equal to 6x minus 1 is equation for this table. Please be sure, try to confirm that if you carry out substitution for x with this equation, that the values of y in this table are the things you're going to get. It has been so nice connecting all these points, all these discoveries made from the graph plotted to be able to get this equation connecting y and x. Again, y is equal to 6x minus 1. See it here repeated on the line of best fit.